All right, so parallel lines. We will define these and stuff. Chapter 2, parallel. The shorthand is this. I slant mine like that. In the book, when you see it, they use just this, but it looks exactly like my 11, so I use a slant. Okay, we're going to be talking about parallel and perpendicular lines in this chapter. Now, realistically, the ideas that we see here are going to show up over and over. The shorthand for perpendicular is an upside down capital T because notice it forms a right angle. Okay, parallel and perpendicular lines is our focus throughout the next 4 sections. Okay, before we get into perpendicular lines, weird emphasis there, we're just going to start with 2.1, and it's kind of redundant. So instead of naming it here and just writing parallel lines, I'm going to call that my first topic, and then this one was just the same, so we don't write it twice. So here we go. Parallel lines. I'm going to make it a vocab. If I were you guys, I would never write the word parallel again. I would always use the shorthand. Now, we just now were able to refine a simple definition for what lines that are parallel mean. They have to be on the same flat surface or plane. And are these lines right now roughly parallel?
Yes.
Are these?
No.
Why not?
Because they're going to meet.
They're going to meet up here if I extend it, right? So we have parallel lines here. Can you think of another definition for it? And that's a harder thing to do. For example, I'm going to set this one on my flat table here. Is there a spot somewhere where it would be parallel? Now, if I were to measure the distance, it is an orange colored pencil away right here. Assuming I can do this without moving my hands and stuff, what's the distance going to be over here? What about here? What if I went all the way over there? So, not the definition that we're going to stick with, but we could say it's 2 lines that never intersect and are equidistant everywhere. They're always the same distance apart. How about in algebra? If I want to talk about this line, how fast it goes up and over, what's that word that we're after?
Slope.
Slope. If these lines are parallel in an algebra class,
They have equal slope.
they have equal slope. Okay, we have 3 interpretations of the same idea. Love it. We're going to go with the purely geometric one for our purposes. And we're just going to say that by definition, parallel lines are coplanar lines. Coplanar, meaning they're both on the same plane, that never intersect. Now, we will probably see the alternative definitions throughout the year. You could say cross if you would like a simpler word than intersect. Cool. Now, when we deal with parallel lines, we're always going to have, at least to begin with, one other additional line that hangs out with us. So we're going to sneak that in as a definition, and then we're going to see how these two interact, which our bell ringer started to kind of get us ready for. We are going to define for ourselves a transversal. Okay, to traverse something means to cross. Like if you're doing some crazy hiking and mountaineering stuff, you might have to traverse like a rock slide where you have to climb really carefully across. You have to go across it. This has the same root. When we think about a transversal, we must cross something else. So we're going to look at this specifically with the idea of parallel lines in mind. And we're going to say that this is a line. And I'm not going to write it, but it could be a segment. It could be a ray also. But line is the easier, all-encompassing. That crosses 2 or more other lines. And same thing, it could be segments or rays, but we're just going to use lines as the umbrella term there. Okay. Parallel lines and transversals. That's all that we're looking at here. Now, a moment ago on the bell ringer, we saw alternate interiors, we saw alternate exteriors. Do you remember any of the other two? Corresponding. One more. Consecutive interior. Now, what we're going to see is all those same angle pairs, and we're not going to define them like strict definition because we're going to see a bunch of theorems today. We get 1 postulate and 3 theorems. My suggestion is we'll use the same picture for all of them, and then we'll sneak in the definitions just naturally in there. So let's dig in. First thing, we are going to get some theorems out of the deal, and I'm going to start by giving us a nice picture. If I told you these lines are parallel, would you believe it? Now, do you know how to mark it to show that they actually and truly are? So a dash, if I do this before you commit to it, this does not say they're parallel. That tells us that their lengths are the same, which all lines are infinitely long. That doesn't mean anything. Now, if you don't know it, and my guess is you've seen it, we put arrows on the end of our lines to indicate they go forever, right? How many times have you put arrows halfway through your line? Okay, welcome to saying they're parallel. This is how we write it down. Now, purely out of convenience, I'm going to name these lines rather. I want to name this line L. How do I write it if I'm trying to name a line with a single letter? Cursive or italic. I'm going to call this L, and I'm going to call this one M. So right now I have two lines that are parallel. L is parallel to M. Okay, we're going to sneak in one more line or ray or segment. And let's knock this out. We're going to name this one T. Any guess on why I called this line T? It's the transversal. So for each of the following, we are going to use this exact same picture. We will number all of our angles together here in just a moment. But what I want you to do underneath is you're going to write the if part of each of the following theorems. If lines, or line L is parallel to M, and T is a transversal. Underneath your picture, I want that if statement. If L is parallel to M, and T is a transversal. And I'll catch up with you guys. So if you didn't catch that, Akis, I'll write it up here. Sorry about that. So every single one of our theorems today in postulates is going to use the same picture. I think we should just draw it once. If line L is parallel to line M, and T is a transversal. Is that what's happening in this picture? L and M are, yep, that's exactly what's happening. Then, and we're going to do dot, 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 and we're going to sneak in some postulates and theorems here. Okay, to make this easier to talk about, I'm not going to name a bunch of points and have to use letters. Let's agree on the following angles. We have 1, 2, 3, and 4. Then on the other side over here, we'll have 5, 6, 7, and 8. So we have a single transversal that cuts two different parallel lines, and it forms 8 new angles for us. Okay, right off the bat, one postulate and 3 theorems. What's a postulate? What's the difference? We get to assume it's true. So for this, rather than defining all of our angle pairs independently, if you can identify them from a picture, I'm fine with the same thing. We don't have to say angle 1 and angle 7 are alternate interiors because they're on the interior, it gets wordy and gross. We'll just work it in here. If you want a wordier version, let me know. Okay, I will switch colors between every postulate and theorem. You obviously don't have to. But let's get started. We have a bunch of theorems and postulates. So first one, postulate. We're in chapter 2, and it's the first postulate that we're going to see. Postulate 2.1. If we need a brain break, please tell me. But postulate 2.1 tells us, yes. Postulate, you're going to miss some stuff, okay? Just a heads up, yes, you can go. Okay, postulate 2.1, we are going to talk about consecutive interior angles. Now, you never have to use the shorthand that I do, but just so that you're aware, because inevitably I will write it, consecutive interior angle. This is how I will refer to this if I'm justifying a proof with something like this. Okay, so we're going to go with your gut first. And I want to make sure that once everybody's done writing, I'll make you all look up here so I can tell everybody's paying attention. So we don't have to write this over and over. All of our postulate, this postulate, and all of our theorems start with if these are parallel and T is a transversal. So I'm not writing that statement every time. Okay, help me identify real quick a pair of consecutive interior angles. 1 and 6 in this picture, or 4 and 7. Now, to clear things up a little bit more, just so we can see it, I'm going to color 3 regions here. I have an orange region over here, I have a green region here, and I have a blue region here. Which one of those regions is interior? The green. That means orange and blue are. Okay, here's my first challenge. I'm going to give you 30 seconds. You're just going with gut. What is the relationship between these two angles? That's the question at hand. How are 1 and 6 related with anything that we know about shapes or angles? I'm going to give you 30 seconds. Any answer is a good answer. Go. 30 seconds. How are 1 and 6 related is the question at hand. What's your gut say?
They're literally the same, like inside. They're in line. Are they? They're consecutive. No. So if he comes back from getting water, can I go back to the third interior?
Yeah.
I'm so tired. It's been 3 hours.
There's a cue going right now. If you're going to pop, go. But if you can hold it. All right. What do you guys think? I heard the right answer somewhere. Okay. Supplementary. What does that mean? They add up to 180. So check it out. You're absolutely right. If L and M are parallel, which we do have, and T is the transversal, which it is, then here's our conclusion. And this is a postulate. We don't have to prove it. The measure of angle 1 plus the measure of angle 2, just kidding, angle 6, sorry, is equal to what? 180 degrees. Now, we could use more formal language. We could simply say angle 1 and 6 are supplementary, but this works. Is there another from our picture and another pair that you guarantee adds up to 180? Now, there's more than those as well. But if we're only looking at consecutive interiors, this is the other side of it. There are 2 pairs of consecutive interior angles whose sum is at 180 degrees. Okay, because it's a postulate, there's no proof needed. Okay, do we need to define what a consecutive interior angle is, or does this picture tell me? Okay. So I'm going to box every single one of them like this so we can see it. Again, I'm going to refer to this over and over and over. Cool. Calc people, when you guys are done, if you just want to peace out and leave your test, I'll come around and grab it. You're also good to keep working. Cool. All right. So let's get another one. We're going to now jump into theorem land. And here we go. Theorem 2.1. And we're going to look at the alternate interior angle theorem. Alternate interior angle theorem. Any guess on how I'm going to shorthand alternate interior angle? Alt int angle. If you don't like my shorthands, don't use them. I will try to be wordy with it, but I would always advocate for you to write less than me. Okay. Give me a pair of alternate interior angles that you see on the board. 1 and 7. Somebody agree with that? Or 4 and 6, right? So check it out. Again, we're not writing it over and over, but we are starting with if these are parallel, which they are, and they have a transversal. Then, here we go. Angle 1 is congruent to angle 7. Alternate interior angles are congruent. And give me another pair of congruent angles that you see here, Henning. 1 and 7 match. Any others? Love it. Angle 4 is congruent to angle 6. Notice, if you can identify that this is the interior region between the lines, alternate just means opposite side of whatever we're looking at. Cool. Could you convince me that's true? Because this is not a postulate. Anybody have a logic through this one? To say that 1 and 7 have to be congruent. Well, we know that 1 plus 6 has to add up to what? 180. And what does 6 plus 7 add up to? 180. So if 1 and 6 add up to 180 and 6 and 7, these have to be the same. There's our proof. We didn't write it, but that's the logic behind the entire proof. Okay. Easy? Okay. And we'll see, like, we'll get practice with them. All right. So we have consecutive interiors, same side interior if you'd rather. We have alternate interiors. Let's also get in theorem 2.2 the corresponding angle theorem. And we're just going to try to blast these out, and then we'll pick which one we want to prove together. Thoughts on how I might shorthand? There it is. Okay. From this, we'll just see if we remember from the bell ringer. On our board, what angle corresponds to angle 3? 7. Notice, angle 3, does everybody agree, is bottom left? What's bottom left of that? 7. There they are. They correspond. What corresponds to 2? 6, and 1 is 5, and 4 is 8, right? What do you think is true about angle 2 and angle 6? They are congruent. Indeed, they are. Here we go. Based on this picture, angle, we'll start with, I don't care, 2 is congruent to angle 6. And angle 1 is congruent to which one?
5.
1 and 5 match. And angle 3 congruent to which one, Yash?
7.
Did you know that, or did you get it answered? And it's okay if you didn't know it. Do you understand why? Is that, you didn't sound very confident. Do you agree they're both bottom left?
Yeah.
That's it. That's all I need. And there's one more pair. What do you got, Ronaldo?
4 and 8.
Angle 4 corresponds to and is congruent to angle 8. Don't mind sound like a broken record. We have to use parallel lines for each of these theorems. They all have the same if lines are parallel and cut by a transversal. All right, there's one more. And let's go red for this one. Last theorem, I promise. So theorem 2.3. I'm going to throw you guys a total curveball here. I'm going to give you the shorthand first. I want you to tell me what it's short for.
Exterior angle theorem.
The exterior angle theorem. Did everybody else have that same assumption?
Yeah.
Love it. So I need to add one more word in here. Bless you. We're going to put alt in there. Exterior alternate angle. And I'm okay with the exterior for the shorthand still. Alternate meaning what with regard to our transversal?
Opposite.
Opposite sides. Can you guys identify a single alternate or exterior angle? I'm sorry.
Yes.
Give me one.
2 and
2 is an exterior angle. Go to the other pair and cross the line, and it's angle 8, right?
8. Yeah.
What do you think is true about those?
They're exterior.
They are alternate exteriors. Do you think there's a relationship between angle 2 and 8?
There's
Congruent? I think so. Angle 2 is congruent to angle 8. And there's one more pair. Sonny, I haven't heard from you yet. Give me the other pair of alternate exteriors.
3 and 5.
Good. Angle 3. And what about them?
They are exterior alternate angles.
And they, because they are
Congruent.
good. Okay. Which one are we proving that's not 2.3? So 2-1 or 2-2? Which one do you guys want to prove? Sure. Let's prove corresponding angles. Okay. For this, you guys get to prove 2.3 on your homework assignment, just so you know. Cool. Now, in general, the shorthand for proof to indicate something's coming, it is PF. Now, we have to be able to indicate, and we're doing 2.2? That's what we said, right? Okay. Proof of theorem 2.2. Anytime we write a proof, I always want you to be able to tell me what are the assumptions, like the if, the given stuff, and what are we after. 2.2, we need to wind up determining that corresponding angles are congruent, right? It doesn't matter which pair of corresponding angles we pick, you get 4 choices. Tristan, which 2 angles do you want us to show have to be congruent? For correspondings. There's not a wrong answer.
25.
So let's show, so there was wrong answers, but let's clean that up. 2 is top left, right? What's the other top left? Let's go with that one. Let's show that angle 2 is congruent to angle 6. Now, I'm going to use the same picture. I'm not going to redraw it since we already have it here. How do we always start a proof? The given information. Now, what is given to us in this? What is the hypothesis of theorem 2.2?
L and M are parallel.
So check it out. Line L is parallel to line M. Nice job, Prime. And what is T? Is the transversal. Okay. Notice that I didn't have to give you the statement. You could work it out because we had the if-then statement written. What's my justification for writing that? Given. All right. Now's the fun part. And these are going to be pretty straightforward proofs. If I'm writing a proof, what I always do is I try to logic through it without ever writing anything down, just so I can have an idea of where I'm going. I need to wind up showing that 2 and 6 are the same. Do you know for sure, guaranteed, that 2 is the same as something anywhere?
Yes.
What's 2 the same as? There's multiple options.
4?
8.
So whoever said 6, I want to pick on you. Not that it's a bad answer, but I want to talk about that. If we're trying to show that corresponding angles are congruent, we can't assume that corresponding angles are congruent to show that. It doesn't work. You can't assume what you're trying to prove. You can never treat it as fact. It will be in the end, I guarantee it, but we're trying to prove that's true. So there's only one other real option. 4 or 8 if you use this, right? Alternate exteriors. Okay, we're allowed to use theorems to prove other theorems. Do you want to roll with 4 or with 8?
8.
So 4 is vertical. That way we don't have to use any of the theorems. If we're trying to use 8, we would have to have this one true, which hopefully you don't think I sit here and lie to you guys. But if we haven't proven it, then maybe we shouldn't use it. Okay, let's use the fact that they're vertical. Okay, now you're going to immediately dislike something about it because I just told you we shouldn't use the theorem to prove a different theorem. But notice the order in which they spit out. I don't want to use this one because it's ahead of it. Could I use this one though? So maybe we will. But I agree with your first statement. Angle 2, I need it in my proof anyway, is congruent to angle 4. Why? Real quick for everybody, help me spell this. Vertical is Vertical. I will never count you wrong for spelling stuff, but the number of Le's instead of AL's was crazy. Vertical. Vertical. Vertical angles, they are congruent. Love it. Notice, I have angle 2 in my proof now. So now all we need is a way to get angle 6 in somehow. We can either try to go from 2 to 6, but we can't use that one. But if only 6 and 4 were linked somehow. So 6 is vertical to 8, but we didn't use alternate exteriors, we used verticals. Yep. So check it out. On C then, what did you guys say just now? Angle 4 is congruent to what?
6?
Why is 4 congruent to 6? I agree with you.
Because they're
They're alternate interior angles. And I know it feels silly that we're using a different theorem, but the order in which they're produced is there. If I'm trying to prove 2.2, I'm not going to use 2.5 to do it. They build on each other. We just happen to pick this one. I'm cool with it. We've talked about that one though. Okay. Now what? If 2 is congruent to 4 and 4 is congruent to 6, how do we link them together? Logically, it's a law of syllogism. What about math? It's the transitive property. And check it out. I will tie these together if 2 equals 4 and 4 equals 6, or is congruent. then we can conclude that angle 2 is congruent to angle 6. And that is a transitive property. Louder, Sylvia?
What is that property?
The transitive, if x equals 2, so if x equals y and y equals 5, then x equals 5. Okay. Transitive property, is that where we're supposed to end up? We didn't use the fact that corresponding angles were congruent to show it was congruent, right? We're good. We're done. Super duper challenging. Okay, good. I hope not. Seem okay? All right. Do I want you guys to write your own proof real quick? Are you sure?
Practice, yes.
We only have 3 minutes.
You do it.
Oh, that's plenty of time.
No, we still have to, write what we were instructed.
Yeah.
I want you guys to prove 2.3. Prove. So I'll tell you, I know we only have 2 minutes, 3 minutes, 2.5. I'm not going to give you homework, and this would have been a homework problem for tomorrow, but we're just taking it off the homework. You're saving time in the long run. I want you to prove to me that alternate exterior angles are congruent. Thanks, guys.
Right now?
How did it feel? Better or worse?
You said alternate exterior angle that
Wait,
are
what
right?
did you want us to prove?
I'm so confused now. He wants us to prove how alternate exterior angles are congruent.
Alternate exterior angle are yes. And we're gonna prove that.
Oh, this is hard.
Oh, sorry, we're doing
Would you mind if I'll do
So
that?
we're proving how the exterior angles are congruent.
You're given is still the same. You should keep your cool. We will pick up. Is it? No, it's 203 on that board.
Did we like work?
Okay.
What if I said
We're gonna pick up here tomorrow at the start of class. You should try it. Like watching me do it, everybody will be like, okay, yeah, that's super easy, it makes sense.
like what if I said
But until you do it, if you've ever had that experience in math, like try it. If you're wrong, we'll build from it. Okay. Other things. I will have your test graded tomorrow. If you feel like it went really poorly, I would strongly advise do not throw your note card away on the way out, because you're probably going to want a note card or to add stuff to your current note card unless you want to make a brand new one. Cool. You guys want to start getting your bell ringers organized? I did not remember to ask you what was challenging about today, but we'll do that tomorrow.
I'll try that.
What's your logic? Can you walk me through it without? Or check it out. Like you could. And then you can do 7 days also 180. Do you know that corresponding angles? Anything right? 13. Screw it, right? Corresponding. Which are we screwing? So we can use corresponding. Right? Check it out. Yeah, I feel like focus over 4 corresponds to 8. They're the same. And like it's right there.